Hello students, today we are going to learn a new lesson which is on rational numbers. So today we are going to learn about rational numbers in different forms. This is teacher Mary Jane and I hope that you listen as we discuss this lesson. Our most essential learning competency is for you learners to express rational numbers from fraction to decimal and vice versa. And that is our reference. This is our reference. Now let us define first what is a rational number. The word rational is derived from the word ratio. Okay, we have here the word ratio, which means quotient. So when we say quotient, that is the result when we divide two numbers. Okay, result when we divide numbers. So we have here another statement. Rational numbers are numbers which can be written as a quotient of two integers, a and b. Okay, so a and b can be any integer. Okay, so do you remember what integers are? Integer includes positive whole numbers. What else? Negative numbers, whole numbers, and of course, zero. Okay, but we have here a condition that b or the divisor should not be equal to 0. Okay, because when that happens, the answer is undefined. Okay, let's say for example 1 is divided by 0, so the answer there or that is undefined. So if you're going to key that in your calculators, it will be syntax error. Okay, so take note of that. So that could be a positive, the numerator can be a positive number or a negative number or 0. It doesn't matter. But for the denominator, we cannot use or we cannot put 0 as a divisor. Here are some examples. So rational numbers are in different forms. So it can be an integer, okay, just like this number, because we can write 5 as a quotient of two numbers, namely 5 and 1. So when we divide 5 divided by 1, the result is 5. So 5 is an integer, 1 is also an integer. Another example, so we have 0. 0 can be written as a quotient of two numbers, namely 0 and 1. Okay, so 0 divided by 1 is equal to 0. And then negative 17, a negative number, can be written as negative 17 over 1. Okay, so again, the numerator and the denominator are all integers. Next, another way of writing a rational number is through fractions. Okay, so this is already in fraction form. So negative 2 is an integer and 3 is also an integer. So that is a quotient of negative 2 and 3. Another one, so we have 5 over 8 or the quotient of 5 and 8, which are both integers. Another one is a decimal. So decimals can be written as a quotient of two integers. So this is a terminating decimal and it can be expressed as 1/2. Later on, we will learn how to express numbers from decimals to fractions and vice versa. And we have here an example of a non-terminating but repeating decimal. Okay, and that can be expressed in fraction as negative 1 over 3. Okay, so those are some examples of rational numbers. Okay, so we have here irrational numbers on the other hand. So irrational numbers are those that do not belong in the set of rational numbers. So it says there, irrational numbers are the set of real numbers that cannot be expressed in the form of a fraction p over q, where p and q are integers. So the denominator q is not equal to 0. So same condition, but for irrational numbers, they are numbers which cannot be expressed using this form wherein p and q are integers. So here are some of the irrational numbers that we have. So the value of pi, okay, that is a symbol for pi, and that the value of pi is 3.14, 15, 92, 65, and we have here an ellipsis. It means that it is a non-terminating decimal, so the value of pi is very long. Okay, so there are a lot of numbers that follows after that. It's non-terminating. Next, okay, so it is a non-repeating and non-terminating decimal. Okay, so we have decimals that are rational numbers, right? Just like the previous examples. So we include repeating decimals, repeating and non-terminating decimals as rational numbers, as well as terminating decimals. But if it is like this, it is non-repeating, at the same time it is non-terminating, then they are irrational numbers. Next is the value of square root of 2. So that is read as square root of 2. Let me write that. So in the next lesson, we are going to learn about square roots or roots. Square root, square root only. Square root of 2. Okay, that is read as square root of 2. And if we are going to square that using our calculator, so the value is also a non-repeating, non-terminating decimal. Next is the value of E, or the Euler's number, and it is also a non-repeating, non-terminating decimal. And of course, you have here the golden ratio. Okay, so it is very long, so we have here an ellipsis. We should remove the extra dots here. Okay, so let me remove that. Okay, so ellipses only comprise of what's this? 3 dots. Okay, let me erase that first. Okay. There you go. So here are the examples of irrational numbers. And let's move on with converting rational numbers from one form to another. So the first one is converting fractions to decimals. Let's go on with some examples. Okay, for number 1, we need to convert 1/4 or 1/4 into its decimal form. Okay, again, we read that as 1/4 or 1/4. So the first step that we are going to do is, by the way, we have here 2 solutions. So for solution 1, we simply divide the numerator by the denominator. Okay, so when we do that, we are going to use this method. So the numerator is always inside the division symbol. Okay, so we have here 1, inside the division symbol, and then we have the denominator outside. Okay, and since 1 is smaller than 4, so we are going to annex zeros. Okay, but before annexing zeros, we have to put a decimal point after the number and then add a 0. Okay, so we have 1.0, but we will first consider that as a whole number. So we are going to divide 10 divided by 4, and the result we are going to put it here. Okay, we will align it with 0. So 10 divided by 4 is what? 2. Okay, so if you have observed, we have included here a decimal point. Okay, we have already put the decimal point in line with this decimal point. Okay, now we follow the same rule or steps in dividing. So after we have divided that, we are going to multiply 2 and 4. So 2 times 4 is equal to 8. Okay, so we have aligned it one's digits to one's digit. So 10 minus 8 is equal to 2, and I think we can annex one more 0, so bring down 0, and we have 20 divided by 4, and 20 divided by 4 is equal to 5. And then we multiply it again. 5 times 4 is equal to 20. And subtracting the two numbers, 20 minus 20 is equal to 0. That means that 1/4 in decimal is 0.25. Okay, or simply 0.25, but it's better if we are going to put 0. Okay, 0 before the decimal point. Another solution is by multiplying the fraction by a number to make the denominator a power of 10. Okay, are you familiar with powers of 10? So the lowest power of 10 is 10 followed by 100 followed by 1000 and then 10,000 and so on. So we have here, yes, those are the powers of 10. Okay, so let us write again our given. We have 1/4. And then can you think of a number which we could multiply with 4 to come up with either 10, 100, 1000? Can you think of a number? Of course, we cannot have 10. Okay, because when we multiply 4 by 2, the result is already 8. So let's try 100. Is there a number that we could multiply with 4 to get 100? That's right. We can multiply the denominator by 25. Okay, and when we multiply the denominator by a certain number, we are also going to multiply that to the numerator. Okay, so we will multiply 1 and 25 as well. After that, we simplify, so numerator times numerator, 1 times 25 is equal to 25, and 4 times 25 is equal to 100. Now, we read that as 25 hundredths, okay? And when we rewrite that as a fraction, so we write 25 and then count the number of zeros in the denominator. So we have 2. It means that we will move the decimal point 2 places to the left. So we have 1 and 2. Okay, there you go. Step by step. So 2 decimal places to the left, and we have 0.25 or simply 0.25. So it's up to you which solution would you prefer to use. Okay, but either both methods are acceptable. Another example. So example number 2, we need to express 2/5 as a decimal form, okay, or 2 over 5. Now, solution 1, we are going to divide 2 divided by 5 again, just like what we've done in example number 1. So 2 divided by 5 is written as this. Okay, again, the numerator or the dividend is inside our division symbol, and the divisor is outside. And again, since 2 is smaller than 5, so we are going to annex a 0, but we have to use or put a decimal point. Okay, now we can divide 20 divided by 5. 20 divided by 5 is equal to 4, and we will align it with 0. Okay, and we have here a decimal point, of course, in line with the decimal point here. Now we multiply 4 times 5, that is equal to 20, and 20 minus 20 is equal to 0. Okay, no need to add more zeros because we already have the answer, which is 0.4 or 0.4. For solution 2, we are going to find a number which we could multiply with 5 to get a power of 10. And I know by now you know what that number is. Okay, so the smallest number which we could get, or the smallest power of 10 that we could get, is 10, right? Because 10 is a multiple of 5. Now, what number have we multiplied with 5? Or could we multiply with 5 to get a 10? Alright, so we have 2. And then, since we are multiplying 2 to the denominator, we are also going to multiply 2 to the numerator. And 2 times 2 is equal to 4, and that's it. Just like what we've done earlier. So write the numerator and then count the number of zeros. So we only have 1 0. It means that we are going to move our decimal point to the left, 1 place to the left. Okay, so the decimal point of this number is here, and we are going to move to the left once. So our final answer is 0.4 or 0.4. So that is the answer for example number 2. Here's another example. So we have example number 3. This time we have a negative fraction. Okay, convert negative 1/3 into its decimal form. So solution 1, or we are going to use solution 1 because we cannot use solution 2 because there is no number which we could multiply by 3 to get a power of 10. So we will use the first method. Okay, so we have, we disregard first the negative sign and simply write 1 inside the division symbol, and of course our divisor, which is 3, outside. Again, we annex a 0, but we first put a decimal point to know where our decimal point is in our quotient. Now we have 10 divided by 3 is equal to 3, and then 3 times 3 is equal to 9. We subtract them, the result is 1. We again annex a 0 and get a 10. 10 divided by 3 is again 3. So it is a continuous process, and 3 here is repeating. So we can put this line or a bar on top of these two numbers and express negative 1/3 as negative 0.33. When we rewrite it, we make sure that we include the sign of the given. Okay, so this is a repeating decimal, so this is still considered a rational number. Example number 4. So we are going to convert 1 and 1/16 into its decimal form. But this time we are going to use solution 2. Okay, wherein we are going to find a number that will make the denominator a power of 10. And what do you think is that number? So we cannot have 10. 100 we cannot. And about 1000, let us check. Okay, so the lowest power of 10 that we could get, or a multiple of 16, that is a power of 10, is 10,000. And what could we multiply with 16 to get 10,000? Or 10,000 divided by 16, the result is 625. And we are going to multiply that as well with our numerator. Okay, so we are going to disregard 1 first and multiply only 1 and 16 by this fraction. So 16 times 625 is again 10,000, and we have 1 times 625 is equal to 625. And then to express that as a decimal, so we write 625 first and then count the number of zeros. So we have 1, 2, 3, 4. That means that our decimal point is here, and we are going to move 4 places to the left. So we have 1, 2, 3, and 4. Let me draw that. Okay, so we have 1, 2, 3, and 4. There is a space here, which means that we have to annex a 0. So we are going to add 1 0 because there is a space here. Okay, so the value of 1 over 16 is 0.0625, and let us not leave our whole number 1. So we have 1.0625. That is the equivalent of 1 and 1 over 16 in decimal. Next, we will do the reverse. So we are going to convert decimals to fractions this time. But first, we are going to deal with terminating decimals. When we say terminating decimals, so it is a decimal with no repeating numbers on it. Okay, to change rational numbers in decimal forms, express the decimal part of the numbers as a fractional part of a power of 10. Okay, so again, you are familiar with the powers of 10. We have 10, 100, 1000, 10,000, 1,000,000, and so on. Here are some examples. We have here a negative decimal, negative 4.5, or we read that as negative 4 and 5 tenths. So upon reading it, we are already writing it or expressing it as a fraction. So negative 4 and 5 tenths, that is how we read it, because the place value of 5 here is in a tenths place. Okay, its place value is in tenths place. So that is read as negative 4 and 5 tenths. We could still simplify this by reducing 5 and 5 over 10. We could divide them, or we could cancel them and divide them both by 5. So 5 divided by 5 is equal to 1, and then 10 divided by 5 is equal to 2. So the simplified form of this is negative 4 and 1/2. Example number 2, so we have 2.713. Okay, so how do you read that? Instead of saying 2.713, so we are going to say 2 and 713 thousandths. Am I right? Yes, because the place value of the third digit is in thousands place. So that is read again as 2 and 713 thousand. So the denominator is 1000, and since we cannot simplify 713 over 1000 any longer, so that is our final answer. Next, this time, how about if we are going to convert decimals to fractions, but we have non-terminating but repeating decimals. Though it is not terminating, but it is repeating. Okay, so the first step is for us to identify the repeating digits. Step 2, count the number of repeating digits. And then number 3, write the numerator and the denominator using the rule below. So the numerator is the repeating digit or digits. If there is only one repeating digit, so that is the numerator. And then the denominator is the number of nines based on the number of repeating digits. Okay, to have a clearer view of that, we have an example. So example number 1, we are going to change 0.2 into fraction. So 2 here has a bar on top of it. It means that 2 is our repeating decimal. Okay, so step 1, we are going to identify the repeating digit or digits, but there is only one repeating digit here, and that is 2. Step 2, count the number of repeating digits, and that is only 1. There we only have one repeating digit. And then we follow this rule for step 3. So our numerator is the repeating digit, which is 2. And then our denominator is the number of repeating digits, but we will put 9. Okay, we will only put 1 9 in the denominator since there is only one repeating digit. That means that 0.2222 or 0.2 with a bar on top can be expressed as 2 over 9. Example number 2. So again, we are going to change negative 1.35 to its fraction form. Again, for step 1, we identify the repeating digits. So we have 2 repeating digits here, which are 3 and 5, or simply 35. And then there are 2 repeating digits here. So that means that we will have 2 nines as a denominator. So we express negative 35 with a bar on top as 35 over 99. And we include our whole number here, negative 1. So we have negative 1.35, 3535, and so on, as negative 1 and 35 over 99 as its a fractional form. Okay, so when we write our final answer, we don't forget to include the whole numbers as well as the sign of the given. Okay, here is another example. So we have 7.215 as a fraction. So the repeating digits here are 2, 1, and 5, or 215. And since there are 3 repeating digits, so we are going to include 3 nines in the denominator. Okay, so to express this part of the fraction as this part of the decimal as a fraction, so we write it as 215 over 999. But our final answer should include the whole number 7. So the equivalent of 7.215 repeated is equal to 7 and 215 over 999. That is our final answer for example number 3. Another, so we have this, but this time we have a digit that is not covered by the bar. It means that only 11 here is the repeating decimal or the repeating numbers. So how are we going to solve or write that in fraction? So we also have here steps that we can follow. For step 1, we identify the non-repeating digits. Okay, and which is the non-repeating digit in our decimal? It is 2. Okay, we have 2 here as the non-repeating digit. And then number 2, count the number of non-repeating digits. So there is only one non-repeating digit here, which is the 2. Number 3, count the number of repeating digits. So there are 2 repeating digits because we have 2 ones. And then number 4, subtract the non-repeating digits from the decimal part. So that will be our numerator. So our decimal part is 211. We are going to subtract our non-repeating digit, which is 2. Okay, so that is how it will look like. 211 minus 2, that is 209. That will be our numerator. Next, the denominator is composed of 9s followed by zeros. So this time it is not only 9s, but we will include zeros. Okay, so it is determined by the number of repeating and non-repeating digits. So the number of 9s is based on the number of repeating digits. Take note of that. The number of 9 is number of repeating digits, and the number of zeros are based on the number of non-repeating digits. Okay, so we will start with writing the number of repeating digits before the number of repeating or non-repeating digits. Okay, so we have 0.211 is equal to 209. We have already obtained this from step 4. And then we have 2 repeating digits, right? So we have to include 2 9s in the denominator, and then we have 1 repeating digit, so we are going to put 1 0 in the denominator. So when we combine those two, we will obtain 990. So that is the equivalent of 0.211 or negative 0.211, wherein 11 is the repeating decimals. Were you able to get that? Let's have another example. For example number 5, we are going to express 2.3215 as a fraction, wherein 15 here is the repeating decimals. So again, for step 1, we identify the non-repeating digits, which are 3 and 2. So we have 32. Number 2, count the number of non-repeating. There are 2 of them. Okay, so that will determine the number of zeros, right? So we'll have 2 zeros later on in our final answer or in our denominator. Count the number of repeating digits. So the number of repeating digits are also 2. We have 1 and 5. So it means that we will have 2 9s in our denominator. Number 4, subtract the non-repeating digits from the decimal part. So this will be our the numerator. Okay, so our decimal part is 3215. We will subtract 32 and we will obtain the difference, which is 3183. This again is our numerator. And then the denominator is composed of the number of 9s, number of repeating, and number of non-repeating. Okay, so the denominator is 9900 because we have 2 repeating and 2 non-repeating decimals. Okay, so here is our final answer. The equivalent of this decimal is 2 and 3183 over 9900. Next example. So we have here a negative decimal. All right. So we follow the steps in solving or in converting non-terminating but repeating decimals to fractions. For step 1, again, we identify our non-repeating digits, which are 8 and 1. Okay, so we have 8 and 1 as our non-repeating digits. Number 2, we count the number of non-repeating digits. So how many? We have 2. It means that we will have 2 zeros in our denominator. Let me just put that, 2 zeros. And then number 3, count the number of repeating digits. We have 1, 2, and 3. Okay, so there are 3 repeating digits. It means that we will have 3 nines in our denominator. So 9, 9, and 9. Next, number 4, subtract the non-repeating digits from the decimal part. So our non-repeating digits is 8 and 1, or 81. And then our whole decimal is 81,547. And when we subtract this two, the result is 81,466. Okay, so we have 81,466. That will be our numerator. And then, there you go. And then we annex, or we put the number of non-terminating and the number of non-terminating, or the number of repeating and the number of non-repeating digits. So we have 3 nines and 2 zeros. There you go. So the equivalent of this fraction is negative 3, or the equivalent of this decimal is negative 3 and 81,466 over 99,900. Now let us check your understanding of our lesson as we answer the following problems. Okay, for the first one, we are going to convert the following fractions to decimals. Okay, we are going to convert the following fractions to decimals. Can you still recall how to convert this? How to convert fractions to decimals? Okay, we have two methods, right? So it's either we divide the numerator by the denominator, or if we could identify a number which we could multiply by the denominator to get a power of 10, we could do that. Okay, so for number 1, we have 2 over 5. Okay, so let us use method 2, wherein we will identify a power of a number which we could multiply by 5 to get a power of 10. And what number is that? That is 2, for us to get the lowest power of 10, which is 10. And then since we are multiplying by 2, we will also multiply 2 with the numerator. So 2 times 2 is equal to 4. Okay, so 4 over 10, that is 4. And again, we will move, if the decimal point is here, we will move the one place to the left because we have 1 0 here. Okay, so 0.4, or we can write it as 0.4. That is the answer here. Example number 2, or problem number 2, we have 1 and 4 over 25. Again, we can identify a number, or we can make 25 a power of 10 by multiplying 4 to get the power of 10, which is 100. So we will also multiply 4 in the numerator. So we have 4 times 4 is equal to 16. We do not forget our whole number 1. So we have 1 and 16 over 100. And 16 over 100 can be written as 0.16. And then we include our whole number, which is 1. So the equivalent of 1 and 4 over 25 is 1.16. Number 3, so we have here negative 3 and 17 over 20. We could multiply 5 to the denominator to get 100. And we will also multiply that by our, or with our numerator. So 17 times 5 is equal to 85. Don't forget negative 3, so we have negative 3 there. And then we have 85 hundredths, or in decimal that is 0.85. And then negative 3, our whole number. So the final answer here is negative 3.85. Number 4, so we have 3 over 8. We can multiply a number. I think it is 10,000. So we could multiply it by a number to get 1,000. And what is that number? It is 1,250. I mean, we could multiply a number by 8 to get 10,000. Okay, the result here is 10,000. So we will also multiply 1,250 by 3, and the result is 5,750. Okay, 5,750. I think we could remove 0 here. So instead of multiplying 1,250, we could multiply 125. Okay, to remove the extra 0. Okay, so that is 575 over 1,000, or simply 0.575. We put 0 because we don't have a whole number, so we have 0.575. Number 5, we have negative 7 over 2. So again, we have 2. We can make it a power of 10 by multiplying 5. So 2 times 5 is equal to 10. We will also multiply 5 by the numerator. So 7 times 5 is 35. Don't forget the negative sign. And then we write it as a whole number first, since there is only one 0 and our decimal point is here, so we will move only one place to the left. So we have 3.5 or negative 3.5 because we have a negative sign in the given. The final answer here then is negative 3.5. Next, so this time we are going to convert decimals to fractions. So as you can see, for number 1 to 5, the given are all terminating decimals, so we have no problem here. Okay, so for number 1, we can write that as negative 2 and then 5 over 10. But we can still simplify it. 5 and 10 are both divisible by 5. So we divide them both by 5. So 5 divided by 5 is 1. 10 divided by 5 is 2. So the final answer is negative 2 and 1/2. Number 2, we have 7.13. So we have the whole number first, 7. So we have 7 and 13 over 100. We can no longer simplify this, so that is the final answer. Next, we have 0.0078. The place value of 8 here is 10,000. It means that we can write this as 78 over 10,000. But we can still reduce it by dividing 78 and 10,000 by 2. So 2 or 78 divided by 2 is equal to 39, and 10,000 divided by 2 is equal to 5,000. So we will write that as 39 over 5,000. thousand. Next, we have 9.03 or 9 and 3/10 or 300ths. So that is the fraction form of 9.03. And for the fifth one, we have -11 and 1600ths, since the place value of 6 is 100. And then we can still divide this by 4. So 16 divided by 4 is 4, and 100 divided by 4 is 25. So the final answer is -11 and 4/25. So number 1, so we have -2 and then 45/99, since we have 2 repeating decimals. Number 2, we have 261/999, because there are 3 repeating decimals. Number 3, we have 21 and 789/999. Number 4, so we have -8, and then 1, 2, 3, 4 is our decimal minus the non-repeating decimals or digits, which is 12, over the number of number of repeating decimals, which is 2. So we have 2 nines and then 2 zeros, because there are also 2 non-repeating decimals. Simplifying, so we have -8 and 1226/9900. Next, number 15. So we have 16 and then 1, 2, 3, 2, 1 minus 1, 2, 3. There are 2 repeating decimals or repeating digits, so we have 9, 9, and then 3 non-repeating digits, so we have 3 zeros. So we subtract 1, 2, 3, 2, 1 minus 1, 2, 3. So that is 11 minus 3, we have 8. This will be 1. We borrow from 3, so we have 11. This will be 2. 11 minus 2 is 9. 2 minus 1 is 2. And then we have 2. So the final answer is 16 and 12,298/99,000.